Good morning, ladies and gentlemen. Welcome to another video at the Pharmacist Academy. Woo! Okay, today we are still in day 2 of the compounding exam, but no fear, I'm here to save you. Okay, so ointments and creams. We're going to talk about the general approach and go over some practice questions. So let's do this. So, introduction. Before we even jump into it, just think about this. Think about a jar of Vaseline, okay? A jar of Vaseline is basically plain. There is no active ingredients in there, right? There's no active medications in there. But then, let's say we wanted to add an active ingredient or an active medication in there. Well, we could do it several ways. And these are literally how a lot of the commercial ointments are made. They start off as like a jar of Vaseline, right, which is usually what we call the base. It has nothing, it doesn't have any active ingredient in there. Then we add the active ingredient, we incorporate it in there, and then you form the ointments that they sell in the pharmacies, for example. So we could do this several ways. If my active ingredient comes as a tablet, okay, I could crush it into a powder form and then incorporate it to that plain Vaseline. If it comes as a capsule, same concept. I open it and I empty out the contents and incorporate it into that jar of Vaseline. What if it's a liquid? That's not a problem. All you have to do is check the properties of that Vaseline, right? If this Vaseline is strictly oleaginous, in other words, it's insoluble in water or liquid, or you cannot incorporate anything into it, such as liquids, then you can't use that. But we do have absorption bases. Now, these are bases, right? Remember, a base was like that jar of Vaseline. So absorption base like Aquaphor here is a type of jar of Vaseline, but this one can actually absorb liquids. Okay, so it's a type of base, an absorption base that can absorb liquids, and you can incorporate the liquid by measuring it into, let's say, a cylinder and adding it, or using a dropper to add it into that absorptive base. You can also incorporate other ointments. You can also incorporate other, like I should say, commercially available or active, or ointments with active ingredients into another ointment, right? So you can incorporate two ointments that have active ingredients in there already. You can incorporate those also. So you use of a second ointment as a source of ingredient to make another ointment. And that will be the first practice problem that we go over, so you'll see exactly what I mean. This example is here for you. Use 1% hydrocortisone ointment to make a preparation of 0.25% hydrocortisone ointment. Some more definitions. So I talked about what absorption base is, right? So absorption base, once again, think of a jar of Vaseline. Okay, there's nothing in there. That's your base. That's your foundation of this ointment. All right. Now we're gonna add an active ingredient in there. If you're gonna add a liquid, okay, make sure that jar of Vaseline is an absorptive, right? A base that can absorb water or liquids. Okay. If it cannot, that's what we call oleaginous base. We also have geometric dilution. This is just a technique of mixing things when you're compounding your ointments. So you usually compound your ointments on an ointment slab, which is literally like a very thick glass square that you compound your ointments on. You may have, let's say, 2 ointments or 3 ointments on that slab that you want to mix together. You want to do this by incorporating a small amount of active ingredient ointment into a larger ointment base, by little, basically. Instead of just having, let's say, 25 grams of plain Vaseline, right? And also 10 grams of active hydrocortisone ointment, and I want to mix those together. You want to take a little bit of the active and mix it with a little bit of the base. All right, so little by little, basically. Levigation. Levigation is when you use a liquid oil or base to reduce powders into finer particles by pressing against it with a levigating agent on an ointment slab. A picture is going to come up so I could talk a little bit more about what exactly that means. Oleaginous base, I kind of talked about it already, right? Think of it as literally Vaseline, right? Vaseline, or a type of base that doesn't absorb water. It's only okay with oil-based products. Trituration is when you use a, let's say, a pesto, right? You get a mortar and a pesto during your compounding. So it's usually when you use a pesto to reduce, let's say, a tablet into smaller particles, right? That's, yeah, it's literally what trituration is. You're just reducing it into smaller particles. Then you have something known as a eutectic mixture. Now, eutectic mixture includes like thymol, camphor, menthol, and or phenol. It could be all of them, or it could be, let's say, two of them, but it has to be at least two. So these are crystalline solids, but for some reason, when we add them together, they're able to form an oily substance, and we could use that to incorporate it into oleaginous bases. If, let's say, you used only one, you probably have to crush it into like finer particles and then levigate it before you incorporate it. If you use two of them, right, and you put them together, they form like an oily substance on its own, and then it becomes very easy to incorporate it into the base. So here's a table kind of going over like the different type of bases. So we have white petrolatum. This is your petrolatum jelly, right? Or even Vaseline, like I mentioned. This type of Vaseline is good for oil-soluble ingredients. You wouldn't add anything liquid into it. Then we have aquaphor. So aquaphor is quote-unquote the other Vaseline that's actually able to absorb liquids. Because why? You might be in a situation where the active ingredient that you want to add to your base is in liquid formulation, right? Not all of them will be solid, or even like another oil product. And lanolin is a type of absorption base also, but we don't usually use that much. Hydrophilic ointment. Now, this is an oil and water formulation, and you're able to add water to this also. Keep in mind that aquaphor is also absorptive, but that one is water and oil. Okay, so the larger face of aquaphor is mostly oil, but you can add water to it. Hydrophilic ointment, the larger face is mostly water. So you could even add even more water to it because it's mostly water, and it's gonna maintain its consistency. So here's a picture of levigating. So levigating is when you use either like an oil or another base, right, to press again powder, right, to press again a substance to make it into finer particles. So let's say I wanted to incorporate some ibuprofen. I wanted to make an ibuprofen ointment. All I have is a jar of Vaseline, and I have ibuprofen tablets. First, I'm going to crush these tablets into like a powder. Then I'm going to take a little bit of the Vaseline, right, and press against this powder. And this is it's adding this pressure that makes it into a finer substance that makes it easier to incorporate into the whole thing. Selecting a levigating agent, they recommend to use the base of the product to levigate. There's no need to add any additional levigating agents, because then you have to incorporate it into the calculation, and that could make things a little bit more complicated. So whatever base they give you, usually you could use that as the levigating agent. Concentration comes into play when you're dealing with ointments. Now, concentration is simply the amount of solute in a preparation relative to the total amount. Now, keep in mind that in this case, the solute that we are referring to are active ingredients. So the amount of ibuprofen powder I added into that jar of Vaseline, the concentration of that's basically what it's referring to. Now, there are different methods of expressing concentration. You could do percentage by weight, where the solute or the active ingredient is in weight, and also the total, right? The total of the whole product is also in weight. You could also do percentage by volume. So the active ingredient in ml per 100 ml of total volume, or you could do weight by volume, like we see in suspensions, right? You have some, let's say, powder like crushed powder, and then you're adding it to a solvent, which is the volume, to create a suspension. So solutes and weight, or active ingredients and weight per 100 ml. Now keep in mind that for ointments, everything is expressed in weight. Okay, and the percentages are always supposed to be weight, weight over weight, unless they specify that it's not. So here you have an example. If you go into Rite Aid and you pick up a hydrocortisone ointment that's 0.25%, what does that mean? That means for every 100 gram of this ointment, there's 0.25 grams of hydrocortisone active ingredient in there. It doesn't mean that the one that you are buying from the store is necessarily 100 grams, right? It could be 50 grams. It could be 25 grams. It could be 10 grams. They just gave you this concentration. So 0.25 gram per 100 gram total, right? So if you bought an ointment from the Rite Aid, which is, let's say, 30 grams, right? The whole thing is 30 grams. So the total will be 30 grams, but the amount of hydrocortisone in there will be different. It's going to be based on the concentration. So you can always set up a proportion. You can always set up a proportion, but just know that the percentages are always per 100 total. I hope that makes sense. Amoxicillin suspension, 10 grams, no, 10%. Simply means there is 10 grams of amoxicillin powder for every 100 ml that you have. You may not have 100 ml. If you have 50 ml, it's not going to be 10 grams in there, right? It's going to be what? It's going to be half of that, okay? It's going to be 5 in that case, right? But the concentration is still the same. The concentration is still the same. It's still going to be 10%. 10 grams and 100. 10 grams and 100. Okay, if you have 50 and you solve for it, it's gonna be less than. You're gonna have less than 10 grams of the amoxicillin powder in there. I really hope this makes sense, because this is straightforward. But I hope the practice problems also help. When you get the prescription like this is how it's usually gonna look like. You're gonna have the patient name, the doctor's information, the DEA. Don't worry about it. There is going to be correct. Assume that is correct. The only thing that you might really need here usually is the weight. Sometimes they might have, let's say, the body surface area. I haven't seen that, but just know if it's if the prescription, if the body of the prescription has like a weight, right? In order to get the dose or whatever the case is, you can always get up here. Then you're gonna have the ingredients as you go, and then you're gonna have a sig here. Okay, now the ingredients usually have a number next to them, and this number is simply telling you this is how much hydrocortisone I want in the whole product. Okay, so sometimes they may give you a specific amount. So imagine the percentage wasn't there. They're gonna say, oh, give us 0.25 grams, right? Also keep in mind, whenever they don't put a unit for the weight is there, whenever they don't put a unit for the weight, it's always going to be grams. So assume this percentage was not there and there was nothing here. It would have been 0.25 grams. Right, so they could present it like that for you to literally add 0.25 grams of hydrocortisone to this product. Or they could say, okay, make this whole product, but we want 0.25% of the product to be hydrocortisone. Sometimes the amount needed is going to be blank, but usually what follows after that is AA. So AA means of each. Okay. AA means of each, and the AA usually comes right before this number. So then this is simply saying that anything that's above that's blank, right, is gonna have the same concentration. So PBZ, menthol, camphor, 0.5% of each should be in this product. Okay. And then usually the base is the last thing presented. In this case, it's petrolatum album. This is regular oleaginous petrolatum. QS up to 100 grams. So if you was making this, you want to start like technically it's saying that we add the hydrocortisone that we need, we add the PBZ we need, we add the menthol we need, we add the camphor that we need. That's gonna form a certain weight, and then you're gonna add enough petrolatum base in order to reach 100. Then they're gonna tell you what's available in the pharmacy, because there are several ways you could get these ingredients, right? For example, hydrocortisone, it could come in a tablet, so you could literally crush the tablet in order to find how much you need to add to the prescription. But in this scenario, it's in an ointment form, right? And it's 1%, and they tell you how much is in there. For example, and then you have the PBZ, comes in a tablet form. The camphor and the crystals usually just have to weigh it out in order to get what you need. And if you paid attention, the menthol and camphor are the eutectic mixture. So you have to incorporate those two together to form an oily substance. But let's follow through. All of this is gonna make sense. So we start with the first one. So here it's saying that, okay, we want 0.25% of this whole prescription to be hydrocortisone, right? So what does that mean? 0.25%. So if you go back to the concentration, and as I mentioned, unless they specify, everything is in weight over weight. So 0.25% in this case is saying, hey, if you make this prescription, right, 0.25% is saying that for every 100 grams of total product you have, right, 0.25 grams of hydrocortisone should be in there. It doesn't necessarily mean that you're making 100 total, right? In this case, we are making 100 total. But let's say if it was 50 or if it was 20, right? This concentration doesn't matter. It's saying, hey, I don't care what you're making. Just know that 0.25 grams equals to 100, right? And whatever you're actually making, then you set up a proportion to find what you need. So here we go. I feel like I'm talking too much, but I really want you guys to understand this. So the prescription wants you to have 0.25% of hydrocortisone. In other words, 0.25 grams of hydrocortisone active ingredient and 100 grams total product. If we had hydrocortisone powder, we could simply weigh out the 0.25 grams and add it to our total ointment preparation to get 0.25%. Right? You're just gonna have to weigh 0.25 grams in that case, because your total is already 100. Right? So the percentage kind of the concentration gave you the answer. So you would just weigh it out. But in this case, we don't have a hydrocortisone powder. You have a 1% hydrocortisone ointment in stock. Okay? 1% hydrocortisone means what? For every 100 total product of hydrocortisone, right, that you pick up, 1 gram is hydrocortisone active ingredient. Okay. I don't need 1 gram. I just need 0.25 grams of active hydrocortisone. So we set up a proportion to determine how much 1% hydrocortisone powder, sorry for the mistake right here, must be weighed out to get 0.25 gram. So here we go. So for every 100 grams of this 1% hydrocortisone powder that we have, 1 gram is the active ingredient, right? Okay. When I looked at my prescription, it said I need 0.25% of hydrocortisone. In other words, I need 0.25 grams and a total of 100. And I'm making 100. So I need 0.25 grams of hydrocortisone. So that would be your active ingredient. But you don't know what total amount of hydrocortisone, 1%, is going to have this 0.25 grams. When you set up the proportion, you're going to get that for every 25 grams of this 1% hydrocortisone ointment, 20.25 grams of active hydrocortisone is in there. So in this case, you'll weigh out 25 grams of the hydrocortisone ointment 1% and put it to the side, because that 25 gram has your 0.25 grams of hydrocortisone that you need. I hope this makes sense. You also need 0.5% PBZ tablets, okay? 0.5%, 0.5% means 0.5 grams in each 100 gram of 0.5 grams in each 100 gram total that you're gonna make, right? So in this case, you need exactly 0.5 grams, which also means 500 milligrams of active PBZ they want you to add. The pharmacy only stocks 50 milligrams, so you divide and you find out that you need 10 tablets. Will give you the 500 milligram or 0.5 grams of total PBZ that you need. You also need of each. Remember the AA? So you need 0.5% of menthol and camphor also. So you're gonna weigh out 0.5 grams of the menthol and 0.5 grams of the camphor and add it together, and it's gonna form an oily substance. Lastly, you need petrolatum album. This is your base. As per the prescription, you must QS up to 100. So you do this last. So calculate how much of this you need. Because sometimes the question may ask you, how much did you actually add to this? You just have to subtract everything else from it, right? So what are you going to subtract? So first, we're going to subtract, okay, so we need 25 grams of 1% hydrocortisone cream to get the concentration of 0.25%. It's supposed to be ointment, not cream, by the way. We need 2 grams of crushed PBZ tablet. That's because, so we need it, here we need a 500, we need a 10, right? We need a 10 tablets. Each tablet weighs 200 milligrams. But inside has 50 milligrams of active PBZ. So wait. So 2 grams. Does that make sense? Right? Each one is 200 milligrams, and you need 10 tablets in order to get the 500 milligrams. Okay, so 2 grams of crushed PBZ tablet, 0.5 grams of the menthol, and 0.5 grams of the camphor. 72 grams of base will be needed in that case. Okay, if you subtract. So 100 minus all of these will give you 72. For the Eutectic Mixture, you just have to, in this case we have menthol and camphor. When you weigh it out, it's going to be solid. When you put it and you let them touch each other on the ointment slab, it's going to turn into oily substance. The PBZ, you crush 10 tablets into fine powder and you keep it on the side. Every time you have a fine powder, you're going to have to levitate. So we're going to have to do this. For the hydrocortisone ointment, ignore this part. This part was not supposed to be here. But the answer, as we went over, you need to weigh out 25 grams of it, right? If you pay attention here, the tube had 30 grams. So we just need 25 grams of it, and that's gonna have the concentration that we need to add. So the method of preparation. So you're basically gonna go as in so using an ointment slab, right? You're gonna form a eutectic mixture by combining the menthol and camphor. So you're gonna put those two solids, 0.5 grams each, on the ointment slab and let them mix. You're gonna add 25 grams of the 1% hydrocortisone on the ointment slab. Excuse me. Add 75 grams of the petrolatum base on the slab also. Use a small amount of the base to mix with the eutectic mixture. So this is like geometric dilution. Use another portion of the base to levitate the PBZ powder that you're going to crush and add. And using geometric dilution, add the levigated powder, right? So you're going to have to levitate the powder by taking a little bit of the powder and using the base to press against it. After that, you want to slowly just combine everything together until you form a uniform ointment. I think in the future I will try to get an ointment slab so I could show you guys, you know, like do a video on that. Alright, here we go. So next prescription here. Hopefully this one is more straightforward for you guys. So we have the ingredients here. So here it's saying 5% zinc oxide. So that's saying that for every the percentage, the concentration in this whole product should be 5%. 5% means 5 grams of zinc oxide in every 100 grams, right? So in this case, we're not making 100 grams. We're making 50 grams. So we're going to have to set up a proportion for that. Burroughs solution, 8 ml that we need to add. Aquaphor QS. Now, if you notice right away, the Burroughs solution is a liquid or a solution. So the base automatically has to be something that can absorb that. You can't just add it. So then they give you the option of using the Aquaphor. Sometimes they may not include the Aquaphor, but you have to just know that you could use the Aquaphor. You could just include it into your calculations, because that's the only way you're gonna get the solution into the base. And then you have the petrolatum also here, and then you're gonna QS to 50 grams in total. So let's see what they gave us. So they gave us zinc oxide 10%. Burroughs solution, they have a bottle, 1 ounce bottle. They have some Aquaphor and they have some petrolatum. Okay. So the zinc oxide, I need 5%. That means for every 100 gram of total ointment, right? For every 100 gram of total ointment that you're gonna make, 5 grams will be zinc oxide. But we are not making total of 100 grams. We're making only 50 grams. So in this case, we need 2.5 grams of active zinc oxide for our prescription. How are we going to get that? Well, the only source of zinc oxide in this case is 10%. So in other words, 10 grams, right? So for every 100 grams of total zinc oxide ointment, right? The 10%. Each 100 grams is going to have 10 grams of active zinc oxide. Okay? But we need only 2.5 grams of zinc oxide. So if you set up a proportion, you're gonna find out that you're gonna weigh out 25 grams of the 10% in order to get 2.5 grams. For the Burroughs solution, it's pretty straightforward. The prescription is asking for 8 ml, so your pharmacy stocks the bottle. So you just have to pour out 8 ml into a graduated cylinder. Here I kind of talked about the fact that the base of the ointment, right? The base is petrolatum, which you can't use, but you also have Aquaphor, so you must use the Aquaphor to absorb this. Now, how much Aquaphor do I need, right? So that I can add this 8 ml Burroughs solution. It's always gonna be 2 times the amount of the solution being added. So if the solution is 8 ml, you're gonna use 16 grams of the Aquaphor in this case. Petrolatum alba, it says QS, right? QS add up to. Okay, so you usually, like I said, usually add the base last, right? You QS up to whatever they tell you to. So the question was asking how much petrolatum album you use. It's gonna be based on subtracting all the active ingredients. So here we have 25 grams of the 10% zinc oxide, 8 grams of the Burroughs solution, minus 16 grams of the Aquaphor. You're going to get 1 gram of the petrolatum album that you have to add. Also keep in mind that the Burroughs solution, pay attention here, I used it in weight. Remember, when you're dealing with ointments, everything in your calculation must be in weight. So if the prescription presents it as even liquid, when you're doing your calculations, if there is a density, you have to convert it into the weight in order to like incorporate it here and do your subtraction. So you're gonna measure out 8 ml of the borough solution into a graduated cylinder and weigh out 16 grams of alcohol. Place the alcohol in your ointment slab and add the borough solution slowly while levigating and mixing it together into a uniform substance. So as you slowly pour out the borough solution from the graduated cylinder, you're gonna like just mix it with the alcohol so that it incorporates it nicely. Weigh out 25 grams of 10% zinc oxide ointment and 1 gram of the petrolatum alba onto the slab, and using geometric dilution, you're gonna mix all the products together. Let's look at another question. Oh yeah, this is nice. So here you have another one here. Once again, you have all your ingredients here. It's usually your active ingredients on the top. Then you have the base here on the bottom. Lubriderm lotion. So you could probably say, oh, I don't know what that is. Is that oleaginous? Is it lotions are usually they usually have like a water component. But let's just assume that we didn't know. So let's just keep going. This is what's supplied to you in the pharmacy based on what's needed in the prescription. So they want you to make a total of 90, right? 3 ounce. Is it 90 ml? No, it's weight, right? It's always weight in this case. You also have glycerin, which is in volume over volume. So that automatically tells you it's liquid. It's more of like a oily substance, but let's just keep going. Sorry. So first thing you need, they said they want the amount of calamine powder in this whole prescription should be 8%. Okay. So 8% means that 8 grams in total of 100 grams. But we are not making 100 grams. We are making 90. So solve for 90 and your answer should be 7.2 grams of calamine powder needed. If we had pure calamine powder, we could just weigh out the 7.2 grams. And in this case we do. So we're just gonna weigh out 7.2 grams. Hydrocortisone, 1%. We have hydrocortisone 1% ointment and cream, but which do you select? Let me show you here. Here they gave you both, right? You need 1% and here in the total. And you have different sources here for you. 1% cream, 1% ointment. Okay. So selection is based on the selection of the whether you use the ointment or cream is based on the base of the prescription. The base is oleaginous, then you would select the hydrocortisone ointment. If it is a cream, then you would select the hydrocortisone cream. Okay, in this case, we're gonna select the cream because the lotion. Let's assume here that it's a. I'm pretty sure, yeah. From what I remember, lotions are usually like cream based, right? So like more of like a water and oil kind of thing, or either oil and water also. So anyways, you need 1%. So in other words, you need 1 gram in a total of 100 grams. But you're making only 90 grams, so you need 0.9 grams needed. So the 0.9 grams that you need, in this case, you're gonna get that from the 1% hydrocortisone that they gave you. Okay, so you just have to set up a proportion, and you're gonna find out how much you need. And in this case, is 0.9 grams needed. I hope this makes sense, right? So look. So the prescription is asking for 1 gram, right? So for 1 gram in every 100, right? But you're not making 100, you're making just 90. So in this case, if you take a look closely and you solve for it, it's going to be 0.9 grams of this hydrocortisone 1% that's supplied to you that you're going to need. Notice how it's the same concentration, but that's totally fine. So even easier, you could just weigh it out, right? You don't need to really set up another proportion. The glycerin is 3% volume over volume. The prescription is requesting for 3%. So here it's just saying 3 ml in a total of 100 ml. So you solve for 90 since that's what we are making. In this case, so in this case, if you solve for 90, you're going to get 2.7 ml. and they provided a specific gravity or the density, so you have to convert it into grams. And this is how much you're gonna add to it. Now the Lubriderm lotion, as per the prescription, kilos to 3 ounce, but they may ask you how much you actually need. So then you're gonna use you're gonna find out how much of each ingredient you have in there. 7.2 of the calamine came from the powder. 0.9 grams of the hydrocortisone came from the 1% ointment, and then you have 3.3 grams of the glycerin, which is it's kind of like oily. It's like an oily thing, oily liquid. But based on a specific gravity, that's the weight for you in order to find out how much lubriderm you need, which is 11.4 grams. Now, when you're mixing this or like preparing it, right, you're gonna weigh out your powder, and then you're gonna use the base to levitate the powder into a finer particles, right, on the ointment slab. You also weigh out your hydrocortisones at 0.9 grams, and also you're gonna use geometric dilution to like mix this with the base. And you have the glycerin. The glycerin is very oily, so it's gonna be easily incorporated into the lubriderm lotion for you to make your final product. And that will be the end of this video. I hope I didn't spend too much time on this, but I hope I went over every crucial point for you guys, and you guys like truly was able to follow along. And if not, please, it's all about feedback, so give me feedback, and if I have to make another video, I will. If I have to explain anything further, I totally don't mind. I'm definitely gonna purchase the ointment slab so that we could not only do the questions but also practice actually preparing it. But if you take your time, pause the videos and follow along, everything should be pretty straightforward. I went over like the three the most difficult questions that you're probably going to see. So I will go now. Feel free to leave comments or anything like that. And thank you for watching this video. Okay, bye.